Hi, I am Shane Brinkman Davis Delamore, and this is Code and Optimism, a show where we explore how to solve problems faster with software. So we've been talking about refactoring largely, and lots of other things related to that, code quality. We've been talking about ways to accelerate our ability to solve problems. Today, I want to kind of look at the flip side of the coin. Like, what is it that actually makes us slow? Let's dive in. So there's several frictions, and thinking it through, I ended up putting them into three different categories: interruptions, obstacles, and complexity. The interruptions, we're not going to go into too deeply today, but these are the environment around you. They are the notifications that interrupt you. They are the meetings that you have to go to. Even harsh noise or harsh light in your environment, any background stress, any emotional stress, and just the general feng shui of the environment that you're in. All these things that pull your focus out of what you're doing onto the environment around you. And here, really, any of the focused work tutorials out there, self-help books, etc., are going to help a bit. But I'm sure in Code and Optimism, we're going to get into this a little deeper at some point in the future as well. Obstacles. Now, these are a little bit more engineering specific. So the first one is whenever we're waiting on the machine to complete something. Now, let me make it clear that waiting on the machine is not just a little thing. You might say, even if you're waiting a couple seconds on the machine, that might be okay, right? But first of all, that adds up over the day. Like every couple of seconds, if you have to do it multiple times throughout the day, it's going to suck up more time over the day, or more time over multiple days, or more time over the month. But more importantly is waiting for the machine means breaking you out of flow. So even though a few second delay may be all you're waiting, it quite possibly can lead to 5 or 10 minutes of low productivity before you get back into flow. And that makes every couple of seconds of interruption a major impediment to being productive. So at the top of it, anyone out there who is managing developers, number one thing, it is totally worth the cost of admission to buy them a fast computer. Or if you're a solo developer, it's totally worth investing in getting a fast computer. When developers cost 100, 200 or more an hour, the price of a fast computer is, $1,000, $2,000, $3,000. And so like 10, 20, 30 hours of development time. So less than a week, maybe even a quarter of the week is how much you're going to spend, and that's going to pay you back within a week or two. Your editor could be slow. IDEs can be famously slow. And that could be because your machine's slow, but it also could be because of all the maybe plugins you got loaded. So that's important. Make sure that you're not waiting on your editor. Compilers, just any language that has a compiling cycle to start with, that's going to be a problem. How do you make it compile fast? And how do you make sure that you're not waiting on the compiler? Slow tests, a famous thing, automated tests. I'm a big believer in automated tests, but I'm a big believer in doing very strategic tests or having different levels of test runs so that your overall waiting for tests when you're developing should be very short. Should be very short to get your tests and get the results so that it doesn't interrupt your flow. Same thing goes for slow CI/CD jobs. If you've got various tests in your dev pipeline, your deployment pipeline, a famous one we've been running into lately is when we got a whole bunch of PRs stacked up and you validate a PR, you merge it in, and then all your other PRs now need to get updated from that branch, and that will re-trigger all of their CI pipeline. And if that CI pipeline is slow, you have to wait 15 minutes and then you can do the next PR, and you have to wait 15 minutes to do the next PR. It's a disaster. There are ways to manage this by staggering your checks and have the really slow checks run much less often and have the common high impact checks in the tasks that you do daily or many times a day. Last, I'll just mention Git-Commit hooks, which have a special place in hell for me. I am a firm believer in committing tens of times a day, if not more. Like committing every 10, 20 minutes is entirely reasonable in my world, because that is your undo. Being able to go back in a few steps from where you've been, like the last time the code was working successfully, is immensely powerful. But it's even bigger than that. Git commit hooks, even if they're fast. So a slow Git commit hook is just a disaster because you're discouraging people from committing. I think that's a terrible idea. They also usually are compiler checks and running your tests and other such things. And you're going to do them again in your CI in just a minute anyway when you push them up to the cloud. So it's really redundant. But even worse is if it is a test, then it can fail. In fact, it probably will fail. And so that's doubly bad for yanking you out of your zone, out of flow. Is that you start the Git commit. You can't just start editing your code and moving forward while the Git commit happens because it could fail. And if it fails and you've already started making new code edits, then all of a sudden you're in this weird place where you got to undo the code edits you just did. So then you can go debug the commit hook failure. And then you got to redo it and you got to run the commit hook again. And so you mostly just end up waiting for a commit hook and it yanks you entirely out of flow. Next one, searching the docs. Whenever we're looking for answers in the API about how to use an API, or even when we're searching our own code trying to find the right answers, it does that. Is that super fast or is it slow? And if it's slow, that's obviously going to shift you out of actually solving problems and into having to just block on loading knowledge into your brain. And here's another big one, which is what I call solving the computer's problems. And these are compile errors, lint errors, type errors. I consider all these things that the computer should be solving for us, and yet we have to solve them. And here's why. These are not the problems we're trying to solve. Say we're making a parking structure management program that manages parking efficiently. It's compilers, nothing to do with that. They're completely unrelated. They're an extra error and an extra problem that we've added on top of the base problems that we now need to solve. These are problems that the computer process, broadly speaking, programming language, all these things have put in our way of solving our actual problem. So compile errors, lint errors, type errors, and manually reloading and recompiling to see changes. The environments have gotten much better at automatically updating changes in the running code, but it's still pretty hit or miss, even with the most cutting edge stuff. And I'll just also throw in managing all your dependencies, installing stuff in your OS, managing your code's dependencies, keeping your dev environment working, all those things. Those aren't problems that have to do with the real problem you're solving. Those are incidentals. Those are solving the computer's problems. And ideally, we wouldn't have any of those on our list. I'm going to say a little about overly secure systems. I've got some experience with this, like stuff that prompts me many times throughout the day to re-enter my password. That is an instant yank out of flow. And it's not I can't see any way to argue that that's actually increasing your security. That's just making it a hassle. And there's a mentality of, we have security standards and everything must just comply, full stop, without actually looking at the pros and cons. And now, over security systems is an entirely another topic. But I don't think it actually results in more secure systems. It just results in decreased productivity. I also put issue tracking on the list. Generally, some type of work coordination has to happen if you've got multiple people working on a project. But issue tracking can very quickly spiral out of control, and it's not solving the real problem, it's solving incidental problems. And you can end up spending a ton of your time just managing issues rather than actually solving problems. So these are obstacles to getting things done. The last of the three categories is complexity. And perhaps one of the biggest ones is building the wrong thing. So that could be over-engineering. That could be product design not validating with users if it's really the right thing you're building. I've said before in this program that I have a totally pulling out of the hat number that 90% of software should never have been written. 90% of software doesn't create, the value generated does not exceed the cost of building it. This is that. And this is probably the biggest single impediment to developing quickly. Building the right thing and building it with exactly the right level of engineering is the most direct way to get to be a 10x or faster programmer. Next is integrations. whenever I'm trying to estimate a project, the number one thing that I'm trying to identify is what are all the integrations. Because if you're just writing pure code in a vacuum, not touching anything else, it's just ivory tower code, you can estimate that pretty closely once you become a relatively experienced developer. You kind of know how much code it's going to take to solve a specific problem. It's all just thought space, and so you know how to link it all up. There's not going to be any surprises. But once you're integrating, and especially integrating in stuff you've never integrated with before, it can be a huge roll of the dice of whether or not it's going to take, it could take weeks or months for something that you thought was going to take a day. So I usually enumerate integrations and I put a heavy budget of time on each integration. And integrations might be an entirely external service, but it also might be a library or some other dependency you're pulling in that's reasonably complicated that you have not used before. One of the other huge time sinks is poor complexity management. And this is part of what we're talking about already. This is non-dry code. So you've got redundant code, but this is also poor modular design. And in general, it means code where there's lots of redundancy, there is poor isolation, and so you have to touch a whole bunch of different bits of code. This is a lot of what we've been talking about in the past episodes, although we've yet to dive into modular design, which is coming up in the future. Last on this list is debugging. We all know we lose a whole lot of time debugging problems, and arguably that's not solving the real problem, that's solving a problem that we created when we created the code. But the key insight I want to hit on here, and this is something that we're going to dive into on another topic for sure, is that there's an old saying in open source that all bugs are shallow with enough eyeballs. But there's a broader concept of that supersedes that statement, which is that all bugs are shallow with good visibility. And that is the key thing. And that is what makes debug slow. Almost all bugs are fast to solve once you understand exactly what's going wrong. And if they aren't fast to solve at that point, it's usually because you've got a major refactor in order to get the solution in place, because there's a whole design aspect you failed to anticipate. And those come up occasionally, but once you get to be relatively, experienced engineer, mostly you're going to spend the vast majority of your debugging time understanding what the bug is, and then fixing it is often a one-liner or even one character. And guess what? We can get a whole lot better at visibility into debugging. So those are the major frictions: interruptions, obstacles, and complexity. So let's imagine a frictionless world. If we have no interruptions, we're going to be 100% focused on the computer, at least the problem-solving tools in front of us. If we have no obstacles, our brain is directly translating problem space into solution space without anything getting on the way. And if our complexity is fully managed, we can add value to our code at superhuman speeds. We can solve the next problem, make the next change, add the next capability in a dash of keystrokes, if all of these things line up. And each of these things can be managed and improved. They can be improved indefinitely, but there's a lot of low-hanging fruit out there. And I'm probably gonna have a whole episode on this, get rid of Git-Commit hooks. There are processes and things that we put in front of ourselves that are considered to be good, but what you have to do is, what is the value that it's given us and what is the cost? And from my perspective, it's the fastest you can get to a solution that meets the requirements. That's always what matters and forever what matters. And so that should be the first metric also, is what's our velocity to requirements. And these little things, these paper cuts throughout the day, it's important to pay attention to all these little paper cuts that slow us down, because keep in mind, they kick you out of flow. And flow is 2, 3, 10x more productive in flow than not in flow right off the bat. And so if you have a 5-second interruption that costs you 5 or 10 minutes of flow, and if that interruption happens multiple times in an hour, that's like, you do the math on there, but that's a couple X of performance hit just because of 3 5-second interruptions. These things matter. They matter a ton. Don't ignore them. So with that, first, these are sort of the high level of each of these items. We're definitely going to go in deeper on these interruptions, your work environment, obstacles, these things that are not problems, not the problem domain you're solving, but incidental problems that we have created for ourselves along the way that we can solve and get around them and put it back to have the computer automatically solve them so we don't have to. And managing complexity, we've already talked a little bit about that. We've got a whole deep dive into modular design coming up, and that it is possible with modular design to write very large systems that are also still very easy to maintain and have very high code velocity. So once again, thank you so much for spending your valuable time with me. I super appreciate it. And what things have you noticed that slow you down? Did I get all of the things that slow us down? Or did I miss some important ones? It's entirely possible. Because part of this is sort of a mindfulness practice, right? Like being aware of what slows you down and taking note of it. And we'll talk a bit more about that as well. But what have I missed? I really want to know. Put some comments down below. Let's have a conversation. And with that, I will just say, remember that all problems are solvable with enough knowledge.